Do you know that you can model and even print your place or neighborhood? Did you know it's possible to create these models with just a few lines of code? And can you imagine teaching mathematics in a way that lets students model their world around them through computational thinking? Welcome to my lesson series, Mathematics Exploration with 3D Printing, bringing data to life with matrices and models. I'm Yosef Dwi Kristanto. I'm excited to share with you an instructional design that transforms the way students engage with mathematics. The lessons are built on the NR-based instructional principles, duality, necessity, and repeated reasoning. They are designed to integrate computational thinking and data visualizations. This helps students connect abstract mathematical concepts like matrices with the tangible world around them. Duality focuses on subject matter mastery, such as matrices as data representations, alongside the development of computational thinking. Necessity creates opportunities that ignite students' intellectual need to engage with matrices through computational thinking. Repeated reasoning provides practice, reinforcing students' abilities to apply computational thinking within the lessons. Together, this principle offers students a bridge between the abstract and the tangible, equipping them with tools to explore, interpret, and model their world. The lesson series is designed to be progressive and engaging with a clear structure that scaffolds learning. The goals are to help students to represent real-world data, such as temperature or topography, in matrix form, interpret the data, and visualize it through 3D modeling and printing, converting abstract data into tangible models. The lessons are structured into 3 parts, each building on the last to deepen understanding and expand students' skills. In Lesson 1, students are introduced to the fundamentals of data visualization and metric-based analysis. The tasks are carefully sequenced to build students' understanding. They show how abstract data can be represented and interpreted using visual and numerical methods. The lesson begins with students observing and interpreting trends using visualizations, sparking their curiosity about temperature patterns. They then critically evaluate the effectiveness of a line chart, identifying its limitations and exploring improved methods of communication. Moving forward, students analyze heatmaps as an alternative visualization, comparing their effectiveness with the line charts and learning to represent data as numerical matrices. Students engage with matrices to extract, interpret, and analyze numerical data, discovering how trends across rows or columns can reveal meaningful insights. To deepen their understanding, they practice summarizing data by reducing a matrix dimensionality through the calculation of average. By the end of this lesson, students no longer see matrices as abstract arrays, but as powerful tools for decoding and analyzing real-world data. In Lesson 2, the foundational concepts of matrices and visualization are expanded further. This is done through the integration of coding in R, enhancing students' computational thinking. The tasks guide students to interact with code and matrices to create dynamic visualizations. Students start by exploring how simple R scripts generate heat maps, learning how data structures relate to their visual representations. This introductory task helps students connect coding basics to data visualization. They then experiment with matrix parameters such as data, number of rows, and ordering methods. This hands-on approach helps them manipulate matrices and observe how changes impact visual outputs. Students apply this knowledge to real-world data, such as overlaps in social media platform usage. They create matrices and heatmaps to represent complex relationships. As they advance, students develop customized heatmaps, including a binary chessboard pattern, learning about color palettes and structured metric designs. Finally, students move from two-dimensional visualization to three-dimensional data representation. They explore how metric-based data can form the foundation for creating 3D models. This progression equips students with a deeper appreciation for the versatility of matrices in representing and visualizing diverse datasets. Lesson 3 immerses students in the process of transforming elevation data into 3D models, combining data analysis, coding, and hands-on creation. The journey begins with students examining a 3D model of Mount Merapi, reflecting on how its visual representation connects to the underlying metric-based data. This activity helps them understand the concept of representing geographic information through three-dimensional visuals. Students then explore shuttle radar topography mission elevation data, learning about data resolution and tiling while discovering its application in urban planning and environmental modeling. Using this data, they analyze its structure as a matrix and transform it into a 3D model. This step helps them understand the relationship between numerical matrices and real-world landscapes. To advance their skills, students utilize RP kits like Resider and Terra to work with geographic data and create detailed 3D models. They explore how coding allows them to manipulate data and visualize it effectively. The final step in this lesson is tangible one. Students 3D print their Mount Merapi models, experiencing the process of transforming digital data into physical objects. These hands-on conclusions bridge the gap between abstract data analysis and real-world applications, leaving students with a comprehensive understanding of data representations and its transformative potential. These lessons open up exciting possibilities for students. They don't just learn math, they see how it connects to the world around them. By working with computational thinking, data visualization, and 3D modeling, students discover how to turn numbers into something meaningful and useful. From exploring temperature trends to designing their own 3D models, students gain skills they can use in real life. They learn to think critically, solve problems, and communicate ideas in new ways. These lessons help students move beyond abstract math, showing them how it's a powerful tool to understand and shape the world. To sum up, these lessons are about more than learning math. They are about making it real, exciting, and useful. By blending concepts like matrices with hands-on activities in data visualization and 3D modeling, students get the chance to explore, create, and understand in ways that stick with them. If you are interested in learning more, I invite you to explore the full lessons. Thank you, and I hope you find the lessons engaging and inspiring.